Okay, so the forced time graphs, if it's not a nice clean shape, then we're going to have to use calculus. Okay, all right. So how we know that the impulse is force times time, right? If we write that as an integral, then I would say the integral of f dt with respect to time. Okay, the integral of the force with respect to time. Okay. All right, so the next one, if the net force on the body varies with time according to Fx equals 3t plus 0.5t squared, where Fx is in newtons and t is in seconds, what is the impulse imparted to the body during the time interval 0 to 3 seconds? Okay, all right, so if I know the impulse is going to be the integral of the force with respect to time, okay, so that'll be 3t plus 0.5t squared, right, dt. Okay, now, if you can do integrals really fast, great. Okay, if you are not yet there in calculus, okay, remember you're just trying to kind of like reverse chain rule it. Okay, so like I'm trying to think of what would the answer be, or like what would I start with if I want the derivative to be 3t plus half t squared, okay? So that is going to be a t squared, right? But there would have been a 2, okay? So 3 over 2, right? Because if I move that 2 down, that would cancel, okay? And then plus 0.5, okay? T, that's going to have to go up by 1. And then when I move that 3 down, I'd want another 3 there. Okay, and then I want to do that from t equals 0 to t equals 3 seconds. Okay, and then I just have to plug it in because that one's not going to matter. So 3 squared over 2 plus half 3 cubed over 3. Okay, so 27 over 2 plus 27 times 0.5 over 3. Okay, and then the impulse is just going to be, oh my gosh. Okay, that's it. I'm just going to get the calculator after this. I better just write this down. 13.5 plus 27 divided by 309 times 0.5. I could have done that in my head. 4.5. Okay, so the impulse is going to be 18 Newton seconds. Okay, good. All right. Okay, another example. Okay, sometimes they might show you the graph. Okay, but luckily they're going to also give us the force function. So force with respect to time is that a 6? Yeah. 6t squared minus 3t plus 1. Okay, and the mass is 7 kilograms. Okay, so what impulse will the object receive in the first 3 seconds? Okay, so we're basically trying to find this purple area, okay, which is not super good. Now, you could kind of estimate it, you know, if it just by counting boxes, basically, if you need to, okay, but let's go ahead and solve it. 6t squared minus 3t plus 1 dt. Okay, and then again, I'm just going to kind of try to like reverse derivative it. Okay, so 6t cubed over 3, right, that'll cancel, minus 3t squared over 2, because the 2 will come down and cancel, plus t, because then that would just be 1, right? Okay, and that's going to be from 0 to 3 seconds again. Okay, again, the 0 doesn't matter. So let's just do 3 cubed over 3 minus 3 times 9 over 2 plus 3. Okay, 2 times 27, so 14.5, no, 13.5. Okay, minus 27 over 2 again, 13.5. Okay, plus 3, so that's going to go away. Okay, so it's going to be 3 Newton seconds is my impulse. Okay. All right, so that doesn't seem right. 3, no, wait a minute, I did something wrong. Oh, 27 times 2 divided by 2. I was like, that's too little, right? Because look, I can see, look, that area is not going to be 3. There's something wrong with that. Okay, here we go. 27 times 2, 54, minus 27 divided by 2, minus 13.5 plus 3. Let's see if I like that better. Minus 13.5 plus 3. 43.5. Okay, I think I like that better, right? Because look, each of these boxes, right, is 10, right? Okay, so 10, 20, 30, 40. Yeah, I like that better. Okay? All right. Yeah, don't miss it because of algebra, for goodness sakes. All right. Okay, so then if the mass started from rest, what is its final velocity? Okay, so the impulse equals the change in momentum. Okay, or if you want to write it like this, okay, either way is okay. All right, and I'm looking for the final velocity. Okay, so mv final equals mv initial plus the impulse. Okay, and then I'll divide everybody by the mass. So the final is just going to be v naught plus j over m. And I'm going to run out of space. Oh, the initial velocity was 0. Well, heck. So just j over m. 43.5 Newton seconds over 7 kilograms. So 6.2 meters per second. So, seems reasonable. Okay, lovely.